But if we had a fraction, could we list where the graph is concave up or concave down? Jocelyn says we can. You got time to kill it, or just high school spring. My daughter is in college in spring break next week. I was over the sun. They were teasing me today. The spring break's over. You're just doing this. I look at my bank account so I know how much money I've got to spend, so I don't go over. I can't be like the U.S. government and just spend money without concern for what happened. All right, so you guys, we're going to have to find the second derivative here. So this is why, like, if we were good in chapter 3 taking derivatives, it will help us with chapter 4 here. If we weren't good, we'll get the extra practice and become good. We're going to have to do the quotient rule. It says take the derivative of the numerator, multiply it by the denominator, then subtract the derivative of the denominator times the numerator. Put it all over the denominator squared. Let's see. X squared plus 3 squared here. On the top we get 2x squared, or 2x cubed. 2x cubed plus 6x. Oh, minus 2x cubed. So those cancel out. So the first derivative is just 6x over x squared plus 3 cubed. Or x squared plus 3 squared. All right, that's the first derivative. We want to figure out where the graph's increasing or decreasing. We figure out where that's 0 or defined. We want to know where it's concave up or concave down. We're going to take the second derivative. So we do the quotient rule again. Derivative of 6x is 6, multiplied by the denominator, minus, to do the derivative of the denominator, we have to do the chain rule. So 2 times x squared plus 3 to the first, times the derivative of x squared plus 3, which is 2x, times the numerator, which was 6x. All over x plus 3, x squared plus 3, squared squared, which would be the 4th. We got to simplify this. What if we factor a 6 and an x squared plus 3 out of everything at the top? Took that out, then we'd be left with 1x squared plus 3. Minus, we took this out, we took the 6 out. So we're left with 2 times 2 is 4. And x times x is x squared. Make sure I did that right. X squared plus 3 to the 4th. Could I let this, now since this is multiplication, let this cancel one of these? And up here I've got this 6, the parentheses, I got x squared minus 4x squared is negative 3x squared. And I get that 3. And it's all over x squared plus 3 cubed. All right, so for concavity stuff, the same thing as for increasing or decreasing. We need to figure out where the second derivative is 0 or undefined. So the denominator can never be 0, because x squared is always positive, so that's nice. So we just take the numerator, the negative 3x squared plus 3, and set it equal to 0. Subtract 3, divide by negative 3. We want to know where x squared equals 1. So x is going to be plus or minus 1. Then we go negative infinity to negative 1. Negative 1 to 1. 1 to infinity. Those are our intervals, and we want to figure out what happens to the second derivative. Well, if we pick a number less than negative 1, 6 is always positive. The denominator's got an x squared, it's always positive, so we really only have to check this part. Number less than negative 1 could be negative 2. Square you get 4, multiply by negative 3, you get negative 12, plus 3 is negative. So it's concave down from negative infinity to negative 1. If we put 0 in there, we're going to get 3, we're going to get a positive. Something bigger than 1, say 2, we're going to get a negative. So we just figured out it's concave down. From negative infinity to negative 1. And then again from 1 to infinity. And it's concave up from negative 1 to 1. Now, Terry, I like what you're thinking of. Picking up on that. See, Terry's saying before we looked at the graph, you know, and by looking at the graph of this, we could sort of see concave up, concave down, but not for sure. But, yeah, that's from the other one. If on this other one, though, if I went back, so if I went back to this one here, how do I want to explain this? What if I graphed the first derivative? Here, look at this first derivative. It's 4x cubed minus 36x squared. Plus 96x minus 64. Now, you know, I'm going to go back to Zoom 6. Standard. A couple of interesting things when I look at this here. We let it go a little higher. I want the y just to stay maximum. I want the y go the same. Now, let's see if 30 was fine. See this maximum right here? If I hit second calc maximum, let's see, I'm at, the x is at negative 2 something right now, so I'm going to enter. So I was to the left of that highest. Now I'm going to hit to the right until the cursor goes past that highest point. Anybody got an idea what they think the x is going to be at that highest point? 2? Terry, how did you know it was going to be 2? Oh, but you guys, think about this. How do you find maximums and minimums? It's where the derivative is 0 or undefined, right? So, if the second derivative is the derivative of the first derivative, wherever the first derivative has a maximum or minimum, the second derivative is 0. And if the function's going up, what do you know about its derivative? It's positive, right? So since this graph is going up until we got to 2, it means its derivative is positive from negative infinity to 2, which means the second derivative is positive from negative infinity to 2, which means it's concave up from negative infinity to 2. Right? And Terry, I think that's why you had that thought on this one here. The first derivative is pretty easy to find, wasn't it? What if we graph this first derivative? You know, sometimes the second derivative gets messy, but if I put 6x divided by x squared plus 3 squared in here, I go to zoom 6, where do you think we're going to see maximums and minimums? -1 and 1. Can't you see them? So here's where you do the old zoom box. I like this zoom box. By Hanson? It was a boom box.
We talked about this last time.
So look, see how this graph's going down until we get to -1, which I'll do second calc maximum. Move the cursor to the left to that lowest point. Hit enter. Oh, did I hit maximum? Yeah. All right, so we'll find this maximum one. Thanks for catching that for me. So hit enter here. So the maximum was at 1. The graph's going up until we get to 1. So from -1 to 1, that's just confirming that it's concave up. Because the second derivative is the derivative of the first derivative. So that's just another way, if you're taking the test, it's with calculator, you get to something where you think you might have messed up the second derivative, you always work off the first derivative.